And welcome back. So hello everyone. So in today's stream, I was just getting a bit caught up before I started a few minutes ago, but so yeah, today I'll basically just be continuing on from last week, where, like I was mentioning before, a lot of the core functionality at this stage has just about been completed. Like there's a number of rough edges, bit of cleanup to be done still, but for the most part, the core functionality is currently there, more or less. And yeah, just basically adding some of the last few features in the next couple of streams. So things like something that should be interesting is destructuring objects with the unspread operation or operator, anonymous functions, operators on the basic data types, and potentially implementing the uh, reflection built in for getting the types of objects. So yeah, so I'm probably just going to dive right in. Now, today's session is going to be a little shorter than usual. Usually I run them for at least 2 hours. Today will just be an hour. So yeah, I'm basically just going to dive right in, continuing on from last week with the object work and diving into implementing object destructuring. So yeah, let's get started. So yeah, first place to begin then is probably to get up some sample data. So let's see what something like this would look like. So if we were to start off with an object like this, then let's see. So if we had an object like that, then with object destructuring, we should be able to do, let's see, something like this. Now, just something that hits me immediately is, and this could be a little, this isn't quite as straightforward as the case of arrays, because with arrays, if we call them the keys are very straightforward. There's either a one-to-one mapping with the items that are being assigned, or there isn't, in which case there's an error. And the keys themselves don't have any names. The names are implicitly the positions of those items within the array. However, in the case of something like this, we first of all have to be careful. So some things that immediately spring to mind are, okay, so first of all, yeah, I think I'm taking the approach that all keys are strings. So that answers the first question of if we had mixed data types in here. So what would happen in the case, say, where, we had something like this, but in this case, even I think all keys, first of all, have to be strings at the moment. So that would, this wouldn't compile anyway. We wouldn't be able to have a 1 in here. We'd have to, in fact, if I even try that right now, then we'll get an error, I believe, at parse time actually, where, yeah, exactly, there's an unrecognized token at this position, so I can confirm that it's position 33. Yeah, basically because we're expecting a string here, and a colon isn't expected at this position. Although I feel like it probably should have complained earlier, because after it reaches the comma, I would have suspected that it should expect um, an apostrophe, but I'm not going to dig too deep into that right now. So all keys are strings, so that's all right. The other thing that is relevant is because these then aren't strings that are being used here, these are going to be actual kind of names. So these are going to have to follow the naming rules of the language. So for example, if we have some like a minus b there, which is a valid key but not a valid name, then we're not going to be able to do something like this, and I don't think doing something like that makes sense either. So you'll have to think about that. Like for that, yeah, that's probably just the way it is. You're only going to be able to destruct, shall we say, legal identifiers from an object. And then the last thing to perhaps consider is whether to follow the Rust convention of if there are extra items in the object that you're destructuring and you just want to ignore them, then you can, so for a list, we can probably do something like this, even though I just thought of this now. So for example, in fact, that could be an interesting exercise. So I'll try that now. Is because that's one thing about lists at the moment is if we have a list of too many items and we just want to say get the first few elements of it. So I'm going to go ahead and print A, B, and C here. Oh wait, C doesn't exist, so just A and B. Yeah, A isn't defined. Because, oh, that's interesting. Oh, so I'm likely getting that on line 1. I hope I wasn't getting it here. The issue here is that I need to actually declare that. And yeah, so in the case of, yeah, so A is 1 and B is 2. But then if we have too many elements in here and we don't actually care about the rest of them, so we, for example, can't bind 4 items to 2 names. So in that case, we could, store the rest in a specific new variable. So increase the size here. So 3 and 4 get put into rest, but if we don't care about them, then we can actually dump them. And the blank identifier is, in fact, I wonder, could that be a shorthand for that, where, we don't bother with the blank identifier? That's something I might consider. So, we have that explicitly, there has to be a one-to-one mapping between the number of elements in the source array and the target array. I'm wondering, does something like that make sense for these guys as well, for objects? Or do we, because it's kind of key based, do we not have to worry about that so much? So I'll get rid of that bit there. And then comes the question as well. So what happens if we, well, first of all, this doesn't make sense as well. So this would be the rename syntax. So if we, so object destructuring as I've kind of observed it recently, there's a fair bit going on. So you can have a field that just has its own name. That means that I don't think this is what hoisting is, but what's effectively happening is you're taking it out of the object's namespace almost and bringing it up into the higher level namespace. In this kind of a syntax, uh, if we call this B prime, um, we're giving it a new name in the higher level environment. And yeah, this could be a useful thing as well then, is to say, okay, all the other items go into here. Yeah, I think that makes sense. And in fact, yeah, that's one of the things that I wanted to do, is to have that kind of a syntax. And then the last thing, and so then this probably isn't necessary in this context then. It's possible, but yeah, is there a major need to be strict in these scripts? I mean, if I did provide this shorthand, it's not a lot of extra work, and it then at least conveys to a reader that there is extra information in that original object that's being ignored effectively. I'll see actually what happens if you do this with an object with two elements. Does this just work fine, I wonder? Cannot unspread 2 items to 3 items. Actually, that makes sense. So that's kind of all right. So what I'm going to say is my default is to like being explicit. Tends to give a bit more information to the reader, I feel. So I'm going to say, yeah, we're going to, it's going to, the number of fields being mapped, all the fields in the source should be represented in the target. Is that a silly thing to require? It's probably a simple enough check. Just thinking about it implementation wise, the check for, whether this is legal then is just, is the size of that equal to the size of this? Or is it, is the size of this less than or equal to the size of this? And if it is, then so long as all the identifiers declared in this section are present in this, then that's all fine. Another option is to have it be configurable, so you can say in your script that, oh, you can allow this or not. But again, actually having that flexibility could increase the complexity of not just the implementation, but for readers, that the actual semantics of the language would change from one environment to another. So that's not something that I'd be keen to go with either. So yeah, it pains me because, and again, this would be if I was the only one writing in this language, I would very much be, I think, of the opinion that I'd require this, but it's more for the sake of ergonomics for other people, because I know, lots of people do like to, uh, not necessarily take shortcuts in this example, but I know there would be a portion of programmers that would prefer to just be able to omit that part, but yeah, I'm going to include it. So yeah, so let's get down to the implementation finally. Now that I've more or less scoped out in my head at least what this thing will look like. So in this case, what does how do I do this for assignments? I think I use the same yeah, I think I use the same expression list declaration for both list declarations and list assignments, so that the same tokens and the same AST is allowed in both places, but the semantics are different. So, you know, I could, for example, do something like in the language there is so far, I could do something like A, B, that, and that'll actually be fine syntactically and will generate an AST. It'll be lexed correctly and parsed correctly, but it'll generate an error at the evaluation time of evaluation. So we'll probably take a similar approach here for the sake of keeping things simple. In fact, that would probably be something that's worth noting in a comment, actually, that the same stuff is being used in both places. Because we could create like because that could be kind of, that section could be cloned and trimmed almost to disallow even constructing an AST with kind of almost an illegal AST, if we call it that. And maybe that would make more sense, actually. Again, this is a bit of a tangent considering I'm meant to be focusing on the array destructuring or object destructuring, but when the time comes for I'm wanting to create a formatter similar to GoFront, and in that case, it's not going to be evaluating the AST, but it probably would be nice if at the time of AST construction, the AST constructor probably would allow this, but yeah, what I'm saying now probably doesn't make it, you know, I'm probably digressing a little bit. Oh, actually, because we're actually allowing an expression on the left-hand side, it probably doesn't make sense to trim it. So never mind, that's actually somewhat irrelevant anyway. Never mind. So yeah, so what I'll do at this point is let me think. Yeah, let's start with the implementation. So let me think as well. So we're also going to allow complicated stuff like this. So C and D. So if B was like that, and we had C is 3 and D is 4, we'd probably have to put something in to protect against the same name being declared multiple times. Similarly, we don't have that for arrays currently, but let me see. So to do something like that, first of all, we'll start off without the unspread operation, because we could actually fully support this, I think, just at the evaluation step by so the error we'll probably get now is a thing saying you can't assign an object. Oh no, there's a token error here somewhere. So what's the, oh, because at the moment, that's interesting as well. So at the moment you can only have string literals as names. So I'm going to have to allow identifiers to be in name slots as well. Now, one tricky bit here is that I'm going to have to distinguish between the two types, and again only allow one form in a given context. So at the moment, just to keep things simple, I'm going to say when you're declaring an object literal, oh, how am I even going to be able to distinguish those, because it's going to more or less look the same. So when you're declaring an object literal, ideally you'd only be allowed to use the string representations. But in the case of an assignment evaluation, then you can use this identifier shorthand. Now another approach as well could be, but it's more verbose, is to say explicitly, okay, it is to specify the strings and say, okay, this string, this key gets mapped to this value. But I think a lot of people are used to this this kind of shorthand by now anyway. So let's see. So this will be object destructuring. And it'll be similar to that's index assignment, that's bind list. So we'll have a bind object thing as well. Again, just reasoning this stuff out in my head before I get stuck into it. So that if it's on the right hand side of an operation. Okay, so actually when we're evaluating this on the left hand side of an operation, we are going to be able to distinguish between that context and the context where it's just being declared like this. So yeah, for now, I'm going to explicitly say that this form is only allowed in the destructuring scenario. And what might be possible then later on is things like number one, allowing this kind of a shorthand in object literals, and number two, allowing this string notation, basically the reverse, where we allow assigning or renaming string keys into local variables. So I might actually just jot that down because that could be important to remember later. Okay, so um, something like that. Now, one last thing then is the kind of order when you are doing a rename. So, um, so does the key coming from the source object go on the left or right of the colon? And I think the convention both in JavaScript and Rust, which are kind of probably two of my main sources of inspiration for this, I think they both take the source key on the left. So I'll probably just continue on with that. The only distinguishing factor with that is probably what makes what's the most intuitive, and realistically the order probably doesn't change the intuitiveness. Though I suppose by convention in programming, what we do in terms of an assignment, we have the thing that we're taking on the right, and the name for it comes on the new name for it comes on the left when we have a binding. So like we could consider this to be a binding. So in that way, the name comes on the left, and this way we're actually changing that and saying that the new name is going on the right. Whether that's a good enough reason to change what people are used to, because if someone is coming from JavaScript, for example, they might come to this and, is that logic, enough justification to, just throw the baby out with the bathwater. So probably not. But I think that argument is kind of a nice one. So I might just jot that down there as well. And this stuff can go into, say, rationale and design decisions and things like that. But then again, this isn't really an apples to apples comparison as well, because this isn't actually a value binding. This is actually a rename. So maybe that doesn't need further documentation. Anyway, I suppose this stream, once I upload it, hopefully, will, if I ever forget why I did it this way, then that might hopefully be sufficient, a sufficient record of what was going on at the time. So yeah, so let's continue on. So I'm going to first allow this this usage of identifiers in this case, and I'll add to the to do as well, actually, because there are a couple of things to do in this destructuring now. So first of all, there's the unspread operator. There's also prevent mismatched numbers of elements. Prevent reassigning the same name more than once. There is, what else do we have? Did I come up with there? I'll put those down in that order, maybe. Maybe under shortcuts for later, or maybe in the R&D section, consider unspread shorthand, e.g. instead of a b dot dot underscore, I allow a b dot dot, and that's not really a significant one, but it's, could be a little nice. Or is it better to just have that first form and say that it's an idiom? Maybe. So I'll have unspread, there'll be renaming. So a prime. And were there other things? I think the rest of them got captured in that R&D note. So I think what is there is probably sufficient. And Sorry, I keep thinking of, oh, are there other things I need to cover? And I keep getting confused between destructuring, which is what we're working on now, where the object is on the left-hand side of an assignment, and and shall we say spreading, where an object is spread across the elements of a newly constructed object. Because even the syntaxes are so similar. But I think what I have here is largely sufficient. So yeah, so in this case, I'll just put a flag here to say is name true and is name false here. Oh wait, no, it'd be the opposite. His name is probably less clear than I want to be, so maybe just is string. Our name is string. And so with that in place, I'll need to extend, oops, what am I doing? The AST so that pair now has that property. So we have bool, and now that I have that in place, first thing I want to do is, well, first of all, I will comment out those. Yeah, I'll need to, yeah, because that's even useful in being able to, like this kind of stuff, in being able to flag, oh, listen, there's another field here that you haven't handled. Do you want to maybe think about handling that? But then the question is, like, that's fine in the case of Rust, where everything does have to be explicit, and you want things to be, you want to catch all your errors at compile time. However, this language isn't even really going to have a compile time as such. It's going to be an interpreted language, and you're only going to encounter these errors at runtime, and you don't necessarily want to have to be explicit with array sizes in that scenario, because you might, part of the utility is of those kind of interpreted languages is being able to prototype things quickly, is being able to mess things around, and you don't necessarily want to have to chop and change between having these dots and not having them. So I know I'm flip-flopping a lot here, but that's the kind of design process. It's more art than science. So I'm going to just put a note for myself here, and I'll tidy it up later. To quick prototyping. Okay, hopefully, hopefully that'll be enough. I've 20 minutes now to implement this feature potentially. So 553, or at least, you know, based on all the items I've added, I'll be maybe able to implement the first step of this. Name is string. So so this is going to be, yeah, this is an object literal, as we can see. So if name is string, then, or if not name is string, then literals must be strings. And so if I do a little test here, I can be like, ooh, this B, that's a regular identifier, so I can just do that perhaps, and the evaluator will come in with a little error being like, no, not allowed, not happening. So that's that. That's the law laid down there. So now I can finally get back to this actual implementation. So in the case of an object, I can't remember what, I assume it's props. We have the right hand side. Will have to be an object as well, where the props will get renamed to props prime, or maybe we'll say LHS props and RHS props. I'll probably have to borrow something there as well. So bind object, can't destructure non-object into object, and let's see, what's BT in this bind type? Okay, interesting. Yeah, that'll be used in calls to bind name. So in that case, that's that new section, and I'll probably copy bind list. Oh, I had a specific handling for binding unspread lists, so that'll be, and bind exact list. So that's if you don't have oh, sorry. So those are the two complements, depending on whether the unspread operator is there. So I'm going to have bind object. It's going to be, so yeah, I'm not having this limit imposed for objects. How are objects defined as well? So object, the left hand side is going to be an AST object, and the right hand side is going to be a valref. So I'll have to get up references to both of those. So if I jump down to, no, it'll be an enum value. And so it's not dealing with unspread items at the moment. So I'll grab the definition of exact list right now. The left hand side We'll start off with the right hand side. An object is a hash map from string to valref. Yeah, that's fine. And then the right hand side then is going to be what? An object which is going to be a vector of prop items. Cool. So then we're not going to be worried about the sizes matching up. In fact, I might put in that comment. Yeah, I think that makes, again, just double checking the decision, and I do think this new decision makes sense because in the case of lists where you have, say, two elements and or you have three elements and you're destructuring it to just get the first element. I think especially because this language is going to be using, say, the likes of lists instead of, say, tuples and things that are tuples, then it makes sense that we have that extra kind of sanity check just for those kind of common use cases. Whereas having this extra constraint on objects where you always have to specify any extra overflow, well, you'll you'll only be able to specify the overflow if the overflow is available. If there's no overflow, you can't use the operator. Then that would impose a bit more constraints on things like prototyping. It'd mean that anytime you just were like, oh, I want to try adding, carry some extra information with an object during the prototyping step, then it's but then it then it depends on how big these kind of scripts and things are going to get. I definitely don't want this to be used for general, the language I'm thinking of, definitely don't want it to be used for general purpose programming. But at the same time, it could be used for relatively big scripts potentially. It's a tricky one. Anyway, I think I'll still continue with this new decision. In contrast with lists, we don't explicitly require that the number of elements being bound is equal elements in the source object is equal number of elements in the target list object. And so we're going to say for each prop item, and this is going to be slightly interesting because we're not going to zip the two. So we're going to say for each property in the left-hand side, and a prop item can be a pair or a spread. So we're going to match. Oh, not list item, prop item. name value and name is string. And object assignment. And so if we have a name, that's kind of funny as well, isn't it? How, because that's the thing, if I'm destructuring, again, the thing on the right is being given this new name. Oh wait, no, it isn't. Whoopsie, my mistake. Yeah, I confused myself. So let's see. So I'll look up. Cool. So yeah, desperately running out of time here. So first of all, we'll go right hand side. We'll retrieve I have to use a hash map get. Oops. Property name in RHS source object. So now we have the value that could be an expression. Just trying to unwrap this in my head. So first of all, anyway, simple things. First, if name is string, then can't you so must use identifier shorthand in that. And then, so what's the name and what's the value in this case. So first of all, actually, this will be something for the to-do list as well. So shorthand. So we'll call it self-bind shorthand. Instead of a. So I'll get rid of so to start off with, we'll just do a gets the value of, no, it's probably easier to do it all at once, isn't it? So in this case, the name is the value in the right hand side, and then the expression on the left hand side is the thing to decompose it. So value is the new left hand side, and we'll call that new RHS. And does that make sense? Yeah, that's an expression. And that might just about do it. I have to move back to this file. So 4 errors, line 450. Oops, 450. Regional expression, all the arms diverge. yeah, that makes sense. Expect an arc, found a reference. Did I need to clone that? 445. Expected a reference. 307. Expected a hash map, but found a reference there. So I'll need to probably bind to that as well. Oh no, I've already bound to that. Do I have to clone that perhaps? And 424 prop item. Oh yeah, should have snake case. It was all over the place. So just on 4 o'clock, we'll see if what I have so far is any good anyway. So first of all, I'll probably keep it relatively lightweight, so I'll start off with just a simple test, even though we've more than that implemented. 304. Just printed. Oh, I didn't save that yet. 304 LHS props. And okay, A isn't defined. I'll just print B there just because again, errors at the moment aren't the best. So yeah, so the error is being flagged at this point. So let's see what's the trouble here. Isn't defined. I should probably be doing this everywhere in this kind of ghost style of kind of manually creating the backtrace. So that's trying to bind. So in this scenario, what's happening? Yeah, I'm probably gonna have to finish up the stream shortly, but let's just take a quick look here at what could be happening. So this is coming in as a var. And this is trying to evaluate A as a value, I'm guessing. Oh no, sorry, is this just... so if I getting stung by my own syntax. Nice. So maybe if I do B then. And B is, yeah, C and D. And then if I instead bind C to C and D to D, B shouldn't be defined in this context, but C and D should be. And then if I change that to E, I can rename it. And that works. Gravy. Nice one. So that, yeah, that's pretty slick. Happy with that, how that went now. So yeah, what I'll probably do is just tidy we'll just move. So I'll add a little bit to the to this. So we have basic. So that's a renamed pair. I'll be honest, that to a certain degree, that kind of wrote itself, and I have to admit, I'm not actually fully sure what's going on. Like, I generally get what's going on, but it's actually doing more than I can rightly comprehend right now. And you know, the actual resolution of the evaluation seems to be like kind of working with a bit more sophistication than I've intentionally written it. So yeah, I'll probably be playing around with this a little more just to make sure that I fully understand it, and also to yeah, make sure that it works. But yeah, that's a nice bit done today now. Fairly happy with that. I've added a chunk more to my workload, but that's all right. And those are all nice things to add. So yeah, I'm basically just going to commit those now and finish up. So yeah, I'll just commit that as is. And git log, git commit, no verify, add support for basic object destructuring, and git commit. Oh yeah, nice. So with that all said and done, that's where I'll be leaving today's stream. Thanks very much for checking out the stream, and yeah, I'll be here again next week. So thanks, and talk to you then.